Hello everyone and welcome to this hands-on exercise for module 2. Here we'll be doing the basic interactions with an IoT processing unit. So let's go ahead and start. To be able to do this, we need a number of things to be fulfilled. The first one, we need to have Visual Studio Code installed in our computers. You can also have Atom, but for this exercise we'll be using Visual Studio Code. And to download these, you can follow the link provided. So I'll go ahead and open the page. So in this page, you should be able to download the Visual Studio Code if you're using Windows, Linux, or Mac. But for this exercise, we'll be using Windows. So all the demonstrations I'm going to show will be for Windows. So go ahead and download and install it. Next, we need Node.js. Node.js is required by PyMaker. Before you install PyMaker, you have to install Node.js. Follow the link to be able to access the download, and I'll open the page. Yeah, so you'll follow the link and get to this page, and we strongly recommend that you download the one to the left, which is 14.17.1 LTS. LTS stands for long-term support, so this is a more stable version and we strongly recommend. Thirdly, you need to install PyMaker. In the next slide we will demonstrate that. And then you need a microcontroller like what you see in this image to the right, bottom right. And you need a USB cable, that is a USB type A to USB to micro USB, as you can see here. So let's go ahead and install. So by now you should have installed Visual Studio Code. If you've installed it, make sure you've also installed Node.js. Once you've installed that, start your your Visual Studio Code. Then the first step would be to click on an extension. Once you've clicked on extension, you will navigate, you'll go to the search section and type PyMaker. Click on the pop-up, PyMaker will pop up, click on it and go ahead and install. So I will demonstrate that to you. So start your Visual Studio Code. Next, click on the extensions. Then go ahead and type PyMaker. I will type PyMaker. It will pop up. Click on it. It will open. And here you will need to install. For my case, I have already installed it, so I don't have to repeat it. But if you've not installed it, then you'll see it written install here. So go ahead and install it. That should take a few minutes and you should be done. Next, we need to connect our microcontroller. So, and to be able to connect it, I will demonstrate how to do that. So here we have the microcontroller, as you can see, and we have the USB cable, which is type A on one end, and then the micro USB on the other end. So here the microcontroller is made up of two components. We have the development board here, and we have the expansion board at the bottom. These two are connected together, so you can easily disconnect them by pulling the development board out, as you can see. So this is the development board and this is expansion board. To connect them back, ensure that the LED, which is the white part here, aligns with the microcontroller, with the micro USB port directly. So connect the pins together and press it firmly and ensure that the micro USB and the LED are aligned with each other. So go ahead, connect the micro USB cable and the USB, connect it to your computer. Once connected, you should be able to see the blue light flashing, as you can see. The LED should be able to be flashing blue. You should also have the USB light in green and the LED light on the expansion board in orange. If you have that, then we are good to go. Go ahead and try that. Ensure that the lights are on. So in this slide, like I mentioned, the LED on the expansion on the development board should be blinking in blue, that is flashing light. Then the USB power should be in green. Some of you may say it's yellow. And the USB power light should be in orange. Now let's move to the next step. Once we've completed that, so we've managed to install Visual Studio Code, we've installed Node.js, and we've installed PyMaker. Then we've been able to connect the microcontroller to the computer. We now go back to the terminal. So start Visual Studio Code. Yeah, it should be able to connect directly to PyMaker. Once you connect it, we have two scenarios here. The one to the left and the one to the right. If you have the one to the right, then there's a problem. That means the terminal is reading from a different COM port, while the microcontroller is connected to a different COM port. However, if you have the terminal reading from the same COM port where the microcontroller is connected, then you should have something like the one to the left. In my case, because I'd already set this, you can see that everything is right. So even if I click on the cursor there and I enter, everything is correct. So which means I'm connected. The terminal, which is Visual Studio Code, is connected to the COM port where the microcontroller is connected. But if you have something like the one to the right, then there's a problem and we need to fix that. And I will demonstrate how to fix that. The first step would be to disconnect your USB, that is a microcontroller, from your computer. And once you've disconnected it, connect it back and go to the section called All Commands and connect it back. I've made it fail so that I can show you how to do it. If it fails, then the next option would be to try and reset the microcontroller. I will show you how to reset that. So let's go to the microcontroller. This is a microcontroller. And at the top here, I don't know if you see it well. At the top here, there's a button. There's a black button. This is the reset button. And to reset the microcontroller, you need to press it until you hear a clicking sound. So it's a really tiny button here that you need to press slightly hard until you hear a clicking sound. And then go ahead, go back to the terminal. So like I mentioned, there are two steps. If you're not connecting, if the terminal is not reading from the same port, the first step would be to reset, that is to disconnect and connect once again and use all commands to connect, that is here. But if that one fails, the next step would be to go to the microcontroller and go to the button I showed you, the reset button, and click on it and go back and try and connect. If it still fails, then we need to go and investigate. Let me show you in the slide. If you've tried these two options and they are not working, then the next step is to identify the COM port where the microcontroller is connected. Now that, for example, in my case here, we can see that the COM port is reading from, the terminal is reading from COM5, but it's possible for your case that the microcontroller is connected to a different port from where the terminal is reading. And to be able to do that, there are a number of steps that you need to follow. The first one would be to go to the device manager to check where the terminal is, where the microcontroller is connected. So I'll go ahead and demonstrate to you how to do that. So in my computer, I will go to the bottom search section, that is, as you can see down here, type device manager. I will go ahead and type. Once device manager pops up, click on it. Then scroll down. You'll find ports, that is in brackets COM and LPT. Click on the arrow to the left. And what you see here written USB serial device COM5, this is a microcontroller. If I disconnect the microcontroller, this will disappear. So for my case, it's connected to COM5. You need to check for your case which COM port it's using. Next, like I mentioned, for my case, it's working well. As you can see here, the terminal is reading from COM5 and the microcontroller is reading is connected to COM5, that's why I don't have a problem. But for your case, if the terminal is reading from a different port and you've checked in the device manager and you can see that the microcontroller is connected to a different COM port, then you need to fix that, and I'll show you how to fix that. I'll go back to the slide. And the first step would be to click on all commands. Now in this case, what we're trying to do is that we're trying to ensure that the terminal is reading from the COM port where the microcontroller is connected. Yeah? So for example, if your terminal is reading from COM9 and the microcontroller is connected to COM10, so which means we need to make sure that the terminal is reading from, we edit it to make sure that it's reading from COM10 where the microcontroller is connected. And to do that, we start by clicking on all commands, as you can see at the bottom here. Next, in the drop-down list, select the project settings. Once you've selected it, this window should be able to open. And in the first line address, you will see where it's written COM. For your case, if the terminal was reading from COM5, you will see that it's written COM5. If it was reading from COM9 like here, then you see it's written COM9. So all you need to do is edit this to match what you were able to establish from the device manager. That is where the microcontroller is connected. So I will go ahead and open that. So click on all commands, go to project settings. And in this case, for my case, I don't have to edit it because the terminal is reading from the right COM port where the microcontroller is connected. But for your case, you need to edit this to match what you were able to establish from the device manager. So if the microcontroller is connected to COM10, as you've established from the device manager, then you need to edit. So go ahead, edit it, and then close it, and it will ask you to save. For my case, let me just change that and put it 5 again, which is the same thing. And when you click that, it says it will ask you to save. Go ahead and save it. Once you've done that, then you will need to go to the all commands and click on connect. Once you click on connect, it should be able to fix it. And you should be able to have it like mine here. And to test it, just click on the cursor down at the bottom and press enter. And if you have it like that, then we're in business. So if you follow those steps correctly, then you should have everything ready. So at this level, your terminal is reading from the port where your microcontroller is connected. And that will allow you to communicate, in other words, to interact with the microcontroller. The next step now we want to do is we want to run an RGB colors. So in other words, we want to interact with the microcontroller and instruct it to give us RGB colors, that is the red, green, and blue RGB colors in the LED. So let's go back to the terminal, select File, open folder, and navigate to the PyCom Basics folder. In the files and folders that we provided you, there's a folder called PyCom Basics. Go ahead and click on it and select that folder. It should be able to open, and to the left you should be able to see a number of files. The first one being alarm.py, chronometer.py, led.py, and several others. So I'll go back to the presentation. So follow the steps and navigate. Let's go back to the page. If you followed all those steps correctly, now click on the rgb.py file, and it should be able to display the script. It should be able to open in the window that is in the canvas to the right. But before we proceed on, the next step we need to do is to upload these files. So the terminal, in other words, the microcontroller doesn't have anything. More or less, uploading is similar to saying installing them into your microcontroller. So I'll go back to the PowerPoint presentation. And as indicated here, you need to upload them. So I'll go ahead and upload them. So once you've opened that, you've navigated to that folder, go ahead and upload. For your case, it will upload it, but for my case, I had already uploaded, so it should be able to upload, because it's going to read, it's going to show you. If you've successfully managed to upload them, now go ahead and click on Run. What do you see? Are you seeing some changes in the LED colors? I will show you mine. I am running the script. So are you able to see this? You can see that the LED here is changing colors. The camera may not be of good quality, but you should be able to notice that the colors are changing in the LED on the development board. Is that okay? If you're not getting that, then you need to repeat the steps once again. You should be able to get red, green, and blue colors changing here. Actually, it's red, green, and yellow. Sorry. If you follow the steps correctly and you're able to have it running like that, we will move to the next step. So we've completed that process. Then the next step is to stop the script from running. As you may realize right now that the changes in the colors it's still running right now. So we need to stop that. And to be able to stop that, we use a Control C. So I'll go back to my script, to the terminal at the bottom. And like I mentioned, if you have the cursor at the bottom of the arrows, the script is still running. We need to stop it by using the Control C. So I've stopped it. If you successfully stop it, you will realize that now the light is now at red. And to be able to take it back to the way it was before, you simply go and press the reset button. So I'll go ahead and press the reset button, and we are sorted. So now that one has stopped. So when you stop the script, it will stop at red, or probably green or yellow for your case. And to be able to take it back to where it was at the beginning, you press the reset button at the top here. Next, we will go to the alarm. So go ahead. So it will select this file. So in the terminal, go ahead and select this. So before we were running the RGB, now select alarm. We don't have to, at this point, we don't have to upload them again because we've uploaded. Once you've selected the alarm, go ahead and run it. What do you observe? It runs up to 10 for 10 seconds and then stops. So it counts 1 to 10 and then stops. The reason being that we've set the script to 10 at this point. Now the next step we will do is to edit this to 20, and we'll see what will happen. So go ahead and edit the line number 12 and save it. Make sure you save it before you run it. After saving it, now run it. What do you observe? Once again, it will start counting, and this time round, let's watch and see if it stops at 10. No, it doesn't stop at 10. The reason being that we've edited it to count for 20 seconds. So up to this level, we've done some exercises on interacting with a microcontroller. So what we've done, we've connected to the microcontroller to our computers. We've started a terminal, and we've performed some communication with the terminal, with the microcontroller. First, we instructed it to give us red, yellow, and blue colors, red, yellow, and green. Next, we started the alarm, and it was counting 10. Then we edited the script, and then we ran the script once again, and it was able to run for 20 seconds. So that's the end of this hands-on training. We've successfully interacted with the microcontroller. See you in the next video. Thanks.